Hello everyone, I'm back today with one more video on communication protocols. So what is this communication protocol? Microcontroller cannot do all the things alone. It needs to communicate with the peripherals like sensors, displays and all. Today I'll be talking about some of the communication protocols which are widely used in embedded systems. Hello embedded learners, I'm Geeta. I work as a technical director at GSAS Microsystems. So today I'll be talking on some of the important peripherals like UART, SPI, I²C. Though there are many other higher end communication protocols like Ethernet, USB, CAN. Those are all higher end communication peripherals because this is on basics of embedded. The most popular used peripherals for serial communication is what I'm trying to cover here. And yeah, if the learners would want me to do a kind of this video for the higher end communication peripherals, I would love to do it. Please let me know. So now let's come to serial communication in embedded. So why this serial communication is required? This is the way the microcontroller uses to exchange the data between the peripherals. Microcontroller exchanges the data with the required peripherals like sensors, displays and everything through this communication. So this is serial communication. So now just watch a quick video on how a microcontroller communicates with these peripherals. So like you can see, it's a display here and this is also a display. So microcontroller is communicating with these two displays through some buses. I have covered about the buses in basics in my previous videos. So through these buses, it communicates between the displays or the sensors. So now let's see what are those protocols which I'll be talking about. Before that, I would like to highlight on before this concept of serial communication came into picture, there was one more concept called as wires. As I said, microcontroller need to talk to the peripherals. It can be PC, it can be display, it can be sensors. So this was through the wires, messy wires. And the disadvantage of it was it communication and it was a costly solution. So then developers came with the concept called as serial communication. Serial communication can be done on one-to-one, device to device, or from one device to multiple device, multi-device or multi-drop functionality. But yes, serial also has some pros or cons that we'll be discussing in this video. So as I said, in this video, I have taken three peripherals, UART, SPI and I²C. Just to show you how the parallel bus works here, you can see high data transfer rate because data is transmitted in a multiple lines together, right? And this is serial bus. This is a cost-effective solution. So serial communication was brought into existence. So now let's talk about UART. So what is UART? Universal Asynchronous Receiver Transmitter. UART plays a very major role in our embedded systems because it's easy to configure. It's just you're transmitting and receiving the data. The UART works with only two wires, or you can say two signals, TX transmit and RX receive. So why UART is very important? I said wherever you are working on an embedded systems which requires wireless communication, could be RF, could be Bluetooth, could be Zigbee. You can take any sort of wireless communication. One device will communicate to another device through wireless though this device may have some antenna and it will send the data through wireless, but directly microcontroller cannot send the data through antenna. Directly it cannot send the data to the antenna. So what it does is it sends the data to the UART and that UART data will be sent through antenna. Similarly on the receiving side, through antenna the data will be received to the UART and through UART the microcontroller will read the data. So UART is a very key peripheral and a critical peripheral for any serial communication related because wireless is again a serial protocol, right? So now let's see what is the data frame, how the data is transferred. So UART is one-to-one communication, a device to device. So one device cannot communicate with multiple devices. not possible. So what is a data frame? It starts with start bit, 8 data bits, 1 parity bit, and 1 sticky bit. So as I said, UART is universal asynchronous receiver transmitter. So there is no synchronous or no clock is involved here. Okay. Then you may ask me how the data is being put onto these pins. Data is set by bit on this. How the clock is generated? That is done through baud rate. So based on the microcontroller what you are using, and based on the UART peripheral and the speed of the operating speed of the MCU, you can configure to the highest baud rate. It can be 2400, 9600, 19200, 38400. The highest is 57600. So this all based on what is the operating speed of the MCU, right? So now we will see what are the advantages and disadvantages of using UART. Though UART is a very critical peripheral, it is easier to program because it is just 2 lines. Even you want to rig up in the hardware also, it is very easy. Probably when you are transmitting the data from one device to another device, you may have to use a transceiver. That is a different story, but theoretical part is this one. Now UART supports full duplex communication. What is full duplex? Means both transmitter and receiver can simultaneously transfer the data. You need not wait for any acknowledgement or something. It just you can transmit and receive the data. So advantage of this is you can use UART for very long distance communication. Okay, and because of this long distance communication, the disadvantage is it is operates at very low speed. Means still you can send the data at the speed of nearly 5 to 6 megabits per second through this UART. But because of this low operating speed, UART is not preferable for higher end applications where data communication speed is a key criteria. So for that, developers came with the next concept, which was I²C, inter-integrated circuits. So unlike UART, probably using with I²C also, it's 2 lines, SCL, SDA. SCL is your serial clock, SDA is your data. Means to that line you can send the data. Everything with the clock. Data is sent from one device to another device. Probably I'll tell you, in I²C there is a concept of multiple slaves. So there is a multi-device functionality. So one device can communicate with many multiple devices. So this one device is called as master. So master slave communication terminology comes for I²C as well as SPI in the next protocol when I talk about, right? So master can communicate with multiple slaves. Then you may ask me how it will communicate. There are multiple slaves. So each slave has a dedicated address. So this slave address can be anywhere in form of 7-bit or 10-bit address. So master will first send the address of the specific slave which it wants to communicate. So first it sends a start packet. Okay, and then it will send the address, the specific slave address, and then it will tell what sort of communication the master wants to have. Is it read or write? So based on that, it will send the read-write packet. So once the slave acknowledges that, because the master is writing a specific slave, so once the slave acknowledges that, then the master will send the data bytes. For each data byte, master expects the slave to send the acknowledge. In any case slave fails to send the acknowledge, master will again reattempt it. So once the entire data bytes are being sent, master will send the stop signal to indicate to the slave, yes, I'm done the communication with you now. So like this process repeats, right? So now let's come to the advantages of it. Advantages is this can be used for short distance communication and it has multi-device functionalities. Those are the advantages. But if you come to disadvantages, cons of it, it operates at very less speed. I²C has a range of operating speeds, low to fast. Low can be 400 kilobits to 1 Mbps. This is the maximum speed which I²C peripheral can operate. So where does this I²C peripheral be used based on your requirement? So it can be used for sensor related application, or you can use it for programming some I²CPROMs, EEPROM or RTC based on the operating speed of those connected devices to your embedded systems. You can use this I²C. So in the UART, I forgot to mention that UART can be used for debugging console. Means if you want to send some data from embedded system microcontroller to the PC, some kind of printf messages, so you can use that. Or for the GPS modules, you can use the UART application, UART peripheral. So now haven't seen this I²C. Let's come to SPI. So why did developers come with SPI? Because I said though I²C has a multi-device support, but that was limited by the operating speed of the peripheral, which was 400 kilobits to 1 Mbps. So then developers thought, what if there is a requirement of higher data rate to be transmitted? Then they came up with the SPI. So SPI stands for Serial Peripheral Interface. Here it is driven by 4 wires. What are those wires? We have clock, we have MOSI, we have MISO, and we have slave select or chip select. So both I²C and MISO are synchronous peripherals, means you need a clock specifically to push the data or to transmit the data from master to slave. So here also you have the concept of master to slave. So what is MOSI? Master out, slave in. Means master is sending the data to the slave. Then we have MISO, where master is receiving the data and slave is sending out the data. Then SS is slave select or chip select. So as I said, SPI also has a multi-device functionality. So here also the master microcontroller can be connected to the multiple slaves here. So how master initiates the communication? Right. So first master will send out the clock signal, and then it will select the required slaves, which slave it has to communicate. If master device to communicate with the slave 1, it will drive the chip select of this particular slave 1 device low, indicating to the slave 1, yes, master is ready to communicate with that specific device. So after it is done, it will shift on the data, 8 bits data or whatever based on the microcontroller you are using, and the data is transmitted from master to the slave through synchronous way using the clock. So similar happens with the MISO as well. So there are actually 4 modes in which the data can be transmitted between the master and slave, or slave and master. So next, the advantage of this SPI, the reason why developers came with SPI was this supports the data transfer rates of anything between 10 Mbps to 100 Mbps, which was very, very good achievement. But again, wherever the speed comes, noise will be captured by this particular signal soon, background noise or the environmental noise. So this specific peripheral had a disadvantage that you cannot use it for longer distance communication. This was only for shorter distance communication. So where all SPI is used. Nowadays you can see even in automotive or modern devices, you have a big display. If you take now vehicle, automotive vehicle, which has a display like you have a Bluetooth, maps, everything driven by you can see that in the dashboard. So such displays can be driven through SPI, Serial Peripheral Interface, where the data transfer speed is you require at a higher speed. Or it can be like you are connecting on your device, you are connecting an SD card. You might have known about SD card, but you want to quickly correlate about SD card, you can take it as a memory card. Probably now the smart mobiles don't require that, but earlier smart mobiles used to have a restricted on-chip memory or the phone memory, where customers used to connect the external memory card, which was nothing but the SD card, secure digital or multimedia card. So this SD card or MMC card also requires the data to be transferred at a higher rate. So there also, in such scenarios also, SPI will come into picture. So now we have seen these 3 peripherals again in theoretical, no coding, no practical, just to understand what are these peripherals, where to use them, and which specific scenario you can use them in your embedded systems. So for the beginners, now next I would give the task. If you just want a simple serial communication just between PC hardware to the PC or microcontroller to the PC, start with UART. Okay, then if you want suppose in your embedded systems you're using sensors, then you use I²C. Or in your device, if you want to connect an I²PROM, or you're connecting an SD card or something for your application, or you're driving a big display, 10-inch display, then consider SPI. So based on this requirement criteria, so embedded learners can select the required communication peripheral for your system. So I'm pretty sure in this video you understood what are these main communication protocols, general or widely used protocols, serial communication protocols, and when to implement based on the scenario and requirement. Thank you for watching. I'll see you soon. Bye-bye.